Here we go. Let's start the timer and read the question. Okay, restore IP addresses. 4 integers. Zero to 255 inclusive cannot have leading zeros, so it cannot be 0, 0, 1. Okay. A string containing only digits return all possible valid IP addresses. Okay, by inserting dots, not allowed to reorder or remove. We can only insert dots and 3 dots. We can insert 3 dots. Okay. Okay, we have an input that's only digits, and we want to insert 3 dots to make valid IP addresses, and we want to return all of those valid addresses in any order. Okay, so I guess the length of the input we could do, so the length would at most be 3 times 4, since each integer can be at most 255. So if length is over 12, at least we know that's invalid. So in example 1, length is 11, which means it will have to be 3 digit, 3 digit, 3 digit, and 2 digits. So how would we, we need to think about how we would solve it, just like using our eyes and brains, just like looking at it, how we would solve it first. So if we have this, I know that I need to use at most 1 that's only 2 digits. The rest has to be 3 digits. So we can start with 255 or 25, and those are the only 2 options. If we start with 25, we see a 5, which is bigger than 255, so that's instantly invalid because it will need to be like this. So that option is over. So we need to have 255, and then we do this. We try with 2 digits. Same case, wouldn't work. It has to be 3 digits. Okay. Now we do this. We try 2 digits. That works. We try 3 digits. That works. Okay, so example 1, we have a clue of how to solve it, but now let's look at the next one. Okay, only 4 digits in total, which means there's only one option. We just have to add a dot between each digit. Okay. What about when we have 6 digits in the input string? So 6 digits, and our options would be like 1 1. We could do 1 1 1 3, or 1122. Yeah, I guess that's the only two possible. So first we try with just one digit. So we try with 1, and we see. Okay, we try 1, and we try 1 again. Then we have 2 2 or 1 3. 2 2 works. 1 3 does not work because there's the leading 0, but 3 1 works. Okay. Now we try with 2. Okay. 1 1 2 or 2 1 2, which does not work because of the leading 0. Okay, so 2 2 1 1. And then we go to 3. Okay, 3 1 1 1. That's the only option. So we have 101.0.2.3. Okay. Oh, this is starting to feel like a pretty difficult question. How would we solve this? Okay, what if let's make up another example. Let's see. Let's take, I mean, we can do the one provided here. So this is 10 digits in total. So what could we have for 10 digits? We could have 1 3 3 3. We could have, okay, let's write 1 3 3 3, 2 2 3 3, 1. I think that's probably it. So if we have 10 digits, it has to be 1 3 3 3 and 2 2 3 3. And when we had 11 digits, what are the options? 2, 3, 3, 3. That was the only option. Okay, so of course we had 12 digits. It has to be like this. What about 9 digits? We could do 1, 2, 3, 3. We could do so if we had 1, the rest has to be 8. We cannot have 1 here because this could be at most 6. Okay. Could we do anything with 2? We need 7. This would be the same thing. Or no, actually no, because it will be different. This will be different IP addresses. Which means even though we have only this combination, we will need to do other permutations as well. So when we have 1 through 3, we not only have to try for 1 through 3, we also have to try for 3, 1 through 3, 3, 3, 1, 3, and 3, 3, 3, 1. So all permutations of that same combination. Okay, getting very troublesome. Alright, so here we have just the possible combinations. And for each combination, we have to try out all the permutations. Okay, let's finish this. 8 digits. We could do 1, 1, 3, 3, 1, 2, 2, 3. If you have 1, 3, and we have 1, 3, 2, 2, that's the same there, or 1, 3, 1, 3, that's still the same. So same combination then. Okay, that's all the options. What about 7 digits? Can have 1, 1, 2, 3. What about 1, 2, 2, 2? I think that's it. Okay, 6 digits, 1, 1. We could do 1, 1, 1, 3. 1, 1, 2, 2. What about 1, 2 something? 1, 2, 1, 2. That'll be the same combination. Okay. 5 digits, 1, 1, 1, 2. And that's the only option. Four digits, then it has to be 1, 1, 1, 1. Okay, that's all we have. So these are, I can ignore that. So these are the possible combinations when we have this amount of digits in the input string. And for each combination, except for these, which are just same for each part. So for all the other ones, we could do permutations. And then while we are checking, we need to make sure it's between 0 and 255, and it's not having any leading zeros. And we want to store them to return. Okay, how would we be able to do this? Invalid. Okay. Well, we do not want to separate into all these different cases, because that's not quite a good solution. What if we are given a string and then we always try with one first until it doesn't work, then we try 1 1 1 2 and 1 1 1 3, and then we try 1 1 2 1 1 1 2 2 1 1 2 3. That seems pretty tedious as well. I mean, that should be a solution. But it doesn't seem very smart. Okay, so if we have, if we are gonna try 1 1 1 1 and then 1 1 1 2 1 1 1 3, and then we do this, so this is gonna be, so we have 1 2 3 3 options for each, and we have 4. That's gonna be 81. doesn't feel very efficient. Oh gosh, it's already been 20 minutes and I haven't even found a solution. Already failed the interview. Okay. I mean, this seems like the only approach that I can think of right now, even though it's tedious. It's at least it looks like it should work. Okay, well, I can't think of something else right now, so let's see if we can translate that into code. So we have a string and we want to try 1111 first, and when we see it's not working, we just move on to the next and then try this, and then we move on to the next. Okay. Well, I really don't want to have four loops. But what would be the other way? If we are gonna do 1, 2, 3, and then 1, 2, 3, 1, 2, 3, 1, 2, 3. Alright. I cannot think of something else right now, so let's just use I like this instead. Okay. That's the first digit. I don't think this is the solution we are looking for. But it's good to start somewhere. Okay. So this string we need to does it say anything about length? Okay, smaller than 20. So not 20. Substring, we are starting at 0 and using this many, and we want to convert this to int. I mean, we can do try parse, we could do convert to int, but is the input okay? How is the input? only digits. Okay, so it will not, this will not happen, only digits. Start index and length. Yeah, that's what I remember. Okay, we start at 0 and length is same as that. Let me see if that will work. And if I mean, it's gotta be from 0 to 255. If it's outside of this range, we can just skip and continue to the next round. And they cannot have leading zeros. Okay. If A1 okay, let's do A1. If A1 is not 0 and it has a leading 0, we skip that as well. In 32 try parse. Okay, let's see if that works. Otherwise, we're gonna do in 32 try parse. I2. So that's gonna start at, oh, so I1, if I1 is 1, and I2 is the length. It should be the same check here, right? A2. Okay. So this is repetitive, which means we need to which means we should be able to refactor. Okay. Where does this start. Well, it will just go to the end, but that should be the same thing there. So if it does work, then we could put this result in the list, which is what would this result be? Let's see, S1. Yeah, S1, first part. Okay. S1 dot S2 dot S3 dot S4. Okay. See if that works. Let's go back to parse. Yeah, we are forgetting a lot of conditions here. Okay. So if S length okay, and if think that's what's missing. Yeah, okay, yeah. So if we're here and there's still a lot left, that it's not successful either. If it's not the same, then we continue. Okay, so that's working. Oh, okay. Very promising. Almost passed all test cases. Let's see. What do we have here? Why would we have this one? Okay. Because the zeros actually was parsed to is it because when we parse 0 0 it becomes 0? Zero, one. Let's confirm that. Is 0 1 0 0 1 0. Yeah, okay. So there's the problem. So the special case when we have two zeros, that does not work. We cannot have two zeros there. Okay, definitely need to refactor this because there's a lot of it. It's really repetitive at the moment. We can definitely put that into a function and then we just call the function. But let's just make sure it works first. 0 1 0. So if we have 0 0 as the string, that is also a pass. If okay, seems okay. We'll clean up later. Seems like it didn't work. 3. Okay. Some reason I did not change this. Weird. Okay, one last. Okay, I have double zeros. Okay, triple zeros. Oh, I mean, I could add that in as well, but it's also ugly at this point. But At least we know that's the last step. Okay, so this should work. I'm really looking forward to refactoring this. Yes. Okay. Not at all the optimal solution. Okay, well, so this runtime is really not that reliable. So this is like efficient enough, I guess, even though this is doing like this is like brute force solution. Okay, let's try to let's do time and space analysis and then try to refactor. So we are doing four loops as mentioned here. For each loop we have only 1, 2, 3, just 3 loops. Well, essentially this is not that bad because this is a constant. It's actually not gonna scale with input n in any way. So no matter what the input is, we are always gonna do this many. So each for loop will run 3 times, and it's gonna run 81 times. If it doesn't run into this continue, so it's skipped somewhere. If it does go all the way, then the result is adding here. So I guess we could actually count this as constant time. And inside we are doing just constant type of work. So I guess this, even though this algorithm is just brute force and stupid, it's still constant time and does not rely or depend on n, the size of the input. What about space? We are not using any data structure. We are just adding results to the list. So this is all just constant. All right. I guess we have constant time and space. Okay. Okay, now let me see if I can refactor this. So we have functions, calling functions instead of this whole blob. Okay, and bummer that I wasn't able to use this somehow, because this seems like it could save a lot of work, but this would mean that we need to separate each cases, all the input length, separate into all different cases, and that wouldn't be recursive like this. This is not recursive, but that will have to be all different cases, whereas this just handles all cases in one algorithm. All right, maybe we have much better solutions. We're gonna check out other solutions later. Okay, let's see if we can refactor this into a function. So we would have, let's see, do we need to return anything? yeah, I guess we could return the list of string. Okay. What do we call this function? It is gonna check if it's valid and then go on to the next part. Let's call it check valid so far. And we need to put in input string. We want to put in, we are, like, if we look at the last for loop, we are using all the I1, 2, 3, 4. So they need to be in the input parameters. Okay, now I'm not super sure if this is the way to go. Okay, I need to go eat dinner. Okay, dinner after this. Motivation. Okay, we have int I1, 2, 3, 4. What else do we need? We need we probably want this result list with us. And what do we do inside? Could we do something like if s length? Start and length. Start and length. So we want to have a substring what if we do, okay, let's see, what if we do boolean else dot add okay, let's see if check valid s start would be 1 plus 2 I3, length will be I4, and result 3. If that returns false, we will continue. Otherwise, we add the results. Okay. So if, oh, that's not the wrong one. If check valid here, and one more, if that's valid, continue, and one more. Zero, one. Okay, it's 0, I1, I1, I2, plus 2, 3, and 4. Okay. Let's hope I did it correctly. Nope. Oh. Okay. So we are passing in a list, an I list. Oh, okay. S1, 2. If what if we do, if that's false, okay, what if this, if that's true, well, I still need to get this. Okay. S1. So where I still have all the I1, I2, I3, I4. I just don't want to do the substring thing Alright, let's just do it. There's gotta be a better way, but substring is substring I1. Well, this gotta be the stupid way to do this. And string plus 3. No, that did not work. It's interesting. What is the problem? Actually, we are not even doing anything with this. Oh, wait. If it's okay, if it's false, then we skip. If it's true, we are actually okay. Can't believe I missed that. Still something wrong. Something is wrong. Okay, let's check. Oh, actually could incorporate this as well. Okay. If s length smaller than start, or instead of start, no, that would be length. Start plus length. Also return false. Okay, let's see, we have 0, 0, 0, 0, we have S01, S01, start is 0, length is 1. That's not false. Substring start is 0, length 1. We have a 0. That's not true. Parse A is 1. A is 1. So why isn't this? Okay, so this should have passed. Next. Right. Okay, console line. I1. I wanna see how many steps it's gone. Okay. Oh. But for this case, it just simply didn't do. Oh. Why is it that it didn't even come to this? Huh. So it's something wrong here. Okay, so that has returned false. So it want to continue in each step. Okay, so why did that return false? Let's see. 0, 0, 0, 0. When we had 0, 1, it returned false. 0, 1. Sub S is 0. So nothing's wrong there. A H 0. Oh, okay, I see. So this is where it returned false. It's weird that it didn't have this problem before. So weird. Before we pull this out into a method itself, it was the same code. So why didn't it react before? Okay, I understand, get it. Okay, if okay, I see. Well, these things happen. Yeah, you're trying to edit too fast and you make a mistake, which only costs you. Alright, so at least we got that fixed. We can remove these console red line. Yeah, I'm trying to stop using Visual Studio to debug, since you won't be able to use Visual Studio to debug during an interview or during your online assessments. So now I'm forcing myself to use console redline and whatever I can in the code itself, instead of debugging stepping in Visual Studio, which I usually do. Okay, let's look at it one more time. That's gonna store the results. We have 4, check valid. If it's not valid, then we continue. If it's valid, we go to the next step. For loop, check valid. For loop, check valid. For loop. So we could incorporate this one somewhere here, but I think it's fine to leave there. Otherwise we need to add an extra line here anyways, and it will be like extra check for all the other check valids. So I think this is fine. And then we check valid. If it's valid, then we add it to the result. Right, I was saying that this is not looking so good. It is working though. Is there any other way? I mean, then we will need to store all these substrings. And do we want to store those substrings then? I mean, we could add extra lines to store there, so we don't have these, but okay, that would be the same thing. I guess this is fine. And we are checking if the length is enough. Then we take out the substring and check if it's 00, 000, and then we convert that to integer to do a final check if it's in the correct range and if it has a leading 0. Otherwise we are good. Okay. Okay, my solution refactored. Usually I'm gonna start looking at other solutions, but it's already been over an hour. So I don't want to make this video super long. So we're just gonna look really quickly, and I will spend more time on it after I eat. Let's see, string and backtracking. So this is supposed to be one of those backtracking algorithms, which I did not do. I will need to work on it later to see if I can come up with the backtracking algorithm, I think. Okay, who can be this code? Oh, it's always so much fun looking at all the other solutions. Oh, look at that. Oh my god. Okay. That does look very impressive. Okay. 4444. Wait a second. Okay, so instead of checking it inside each loop like I've done, we're just gonna try out all the different kinds of ABCD combinations, and then we just take out the corresponding substring and convert to integer, and then check if they're all valid. This is indeed much smarter. Oh, okay. Very nice indeed. Huh. Oh, we do indeed have a recursive solution here. Okay, so I've checked out the top 3. Okay, I'm gonna stop recording now, but I'm gonna come back, and now that I've seen the idea behind the first solution, I'm gonna rewrite my solution to use that idea. So usually I will just like look through quickly and get the idea, then I will code that myself instead of copying their code or just looking at their code and somehow just doing it in another language. So it's always good to try to code the better idea all by yourself. Much better way to learn. Okay, blah blah blah, that's enough. It's already too long. Yeah, it took me, unfortunately, a lot of time to solve this. So, okay, I'm gonna go have dinner now. It's 8 p.m. See you next time.